Hello everybody, my name's Nick Setzer, and today we're going to be talking about limit laws. So before we get into the actual laws, let's go over some definitions. In mathematics, a limit is the value that a function or sequence approaches as the input or index approaches some value. Limits are essential to calculus and mathematical analysis in general, and are used to define continuity, derivatives, and integrals. We use limit laws to help us manipulate functions in order to find the limit of otherwise too complex functions. I've given some rules that we're going to follow when we go through the examples that I'm going to give below. They're essential so that it makes it a bit easier for us to understand these laws. So the first law that we learn is the scalar multiplier law, which states that when a function is multiplied by a constant, the limit of that function is multiplied by the same constant. So as we see here, when f of x is multiplied by 5, the limit of f of x to whatever value is also multiplied by 5. The second law that we learn is the sum and difference law, and that states that the limit of two functions added or subtracted equals the sum or difference of the limit of those two functions separately. So basically the idea of the limit as f of x plus g of x approaches c is the same as the limit of f of x as x approaches c plus the limit of g of x as x approaches c. It's almost like the distribution property, but instead of distributing constants, we're distributing that limit set. The third law that we learned is the product and quotient law. This states that the limit of two functions multiplied or divided equals the product or quotient of the limit of the two functions separately. So it's very similar to the sum and difference law, except instead of adding and subtracting, we're doing multiplication and division. So basically it states the limit of f of x times g of x as x approaches c equals the limit of f of x as x approaches c and the limit of g of x as x approaches c. Next we have the power law, which states that when a function is raised to a power, its limit is also raised to that same power. So it's pretty self-explanatory. The limit of f of x to the power of 2 as x approaches c equals a to the power of 2, a being the limit of f of x as x approaches c. Next we have the root law, which is very similar to the power law, except instead of raising something, we're taking the root of it. The root law states that when a function has its root taken, its limit is also taken of the same root. So the limit as the square root of f of x as x approaches c equals the square root of a being the limit of f of x as x approaches c. Lastly, we have the horizontal line law, which basically states if you take the limit of a constant, the limit will equal that constant. So basically the horizontal line law states that when the function is a constant, the limit will always be that constant, which makes sense because if you plug in whatever you're approaching into that value, it'll always equal that value. There's no x value to plug into. So it will always equal that constant. So to end this little presentation, we have a couple problems to work out. So the first one is the limit of x cubed over x squared minus x plus 7 square root times x as x approaches 2. So first what I did is I used the product and quotient law, which allowed me to separate it into the limit of x cubed as x approaches 2 divided by the limit of x squared minus x plus 7 square root as x approaches 2 times the limit of x as x approaches 2. Then I was able to use the root and power law, which allowed me to plug into all these x values while keeping our roots and powers in line. And if you simplify this, you get 4 over 3 being the limit of this function as x approaches 2. The second problem we have has a little trigonometry in it. We got the limit of secant x minus 1 over x as x approaches 0. So we have to do a little algebraic simplifying before we can use any of our rules that we've learned. First I simplified secant x to 1 over cosine x to get 1 over cosine x minus 1 over x. Then I simplified it a little bit more to get 1 minus cosine x over x times cosine x. Then I was able to separate these into two different fractions, and I get 1 over cosine x times 1 minus cosine x over x. So now I can use the product rule to distribute this limit as x approaches 0 to get the limit of 1 over cosine x as x approaches 0 times the limit of 1 minus cosine x over x as x approaches 0, this using the product rule. I'm able to plug in 0 into both of these values, and I get 1 times 0. So that means the overall limit as x approaches 0 for this function is 0. So that basically wraps up this little presentation that I've had. I made a worksheet that I'm going to be handing in as well. If you have any questions, you can contact me. Otherwise, have a good day.